Kinda, not really. It's kind of a pain, to be honest. I'm doing the math down here as well to make sure that I'm correct, but it should be pretty spot on accurate, hopefully. I'm just trying to implement the formulas. So A is equal to C, which C would be 114 because we solved that, right? Sine of C, no, BA times 144 would be 20, which is lowercase c, so that's supposed to be lower c. Okay, yeah, that's right. Lowercase c times the sine of, yeah, so it'd be 20 times the sine of A, which the sine of A is 40 degrees, divided by the sine of C, which is 114. Here's my calculator. And then we're only solving for the radians, not for degrees, so we don't need to do the inverse. So we have 20 sine, I'll make sure this is in degrees though. Okay, sine of 40 divided by sine of 114. get 14. I'll just round to 3 decimal places. So 14.0723. So that is a 0.072. Alright, so that's A. Gonna factor this. So then B would just be the sign of A over A. Okay, let's actually check this to make sure that we are returning the correct values real quick. So let's say solve for the triangle. We have big A, which is 40, and 26, and 20. Oh, we need to info the answers. Info angle C is, I'm gonna say find angle C of angle C. Also want to info side A is of find side A of side A. That should be a positive number. Oh, we need to flip this. So we do 180 minus 144. Let's use trace instead, give it a bit of a nicer format maybe. Oh, I did not mean to close that. Okay. I don't know why we have the space or the new line there, but I don't mind it. Let me just make sure those are correct. So C is 144 or 114, and then side A is 14.072. Okay. So now to find side B, we'd have to do the sign. We'd have to do sine of A over little a is equal to sine of B over B, which will then, since we're solving for B, would be B is equal to A times the sine of angle B divided by the sine of A. Okay. Actually, we don't need to put these as a const, actually. We could just have them as something else, but it's just easier. Const, find side of B, side underscore B, dash. It's gonna be equal to, say, the side of A, so, right? Because, yeah, so find side A of the computed value of side A times the sine of, we need to convert the degrees to radians, of B, which B is a given, and then we need to divide that by the sine of degree to radians sorry, responding to Discord, of, we would have A, which A is a given. Yeah. Right? Because we have sine A over A is equal to sine B, cross multiply. We get A is equal to, we would get angle B, because we're solving for B. Angle B is equal to sine A times the sine of B divided by the sine of A. Yeah, that's right. So trace We're also going to do this on paper as well. Side B is, I'm going to say, if I can spell find correctly. Find side B, side B. Okay, so we should get B is 9.597. Let's see. Let's do this on hand here. So we know B is, let's actually just double check this. So we're solving for B, so we know A is, oh, but we need to use the full value of A, which is a problem. So we're gonna have to store the value of A. A is, ooh, that's a long number. Fun. Hey, what's up, Ender? Hello. Also, hello, Tyler. Welcome to the stream. Law of sines and cosines, fun stuff. Well, it's alright. It's not bad. Actually, can we use the three? Sorry, I'm just going back through my notes here. I don't know if we can use. Nope, it's a bit more forward here. It's for the degrees. For if we have an angle. No. That's what I want to see. But we only have one triangle here. Can we use... We can use it. Okay. Cool, so then that shouldn't really be much of a problem, I believe. But I do trust these numbers because the math is correct. So let's actually just do this real quick. Let's use the A. So we have 14.072 times the sine of B, which B is 26, degrees divided by sine of A, which A is 40 degrees. Maths. What's up, Ducky? Sergeant Duck, welcome to the stream. With me doing my math homework. Okay, so we have, oh crap, I didn't mean to do that. Let's store this value. And we'll have sine of 26 divided by the sine of 40. Make sure our degrees are, of course we get an error. Can we copy it in my calculator? I don't know if my calculator can copy. But we can do that. Of sine 26 divided by the sine of 40. 9.597. Yeah, that's right. Alright, cool. Awesome. So our maths here is correct. So let's add that to our thing here. So C is 1/4. Angle A round to 3 decimals. So our side A is 14.072. B is 9.597. There's 30 of these fuckers. Okay, so we have the same problem again, which A with 2 angles and a side, which is we have this time we have this angle, which is going to be the same problem pretty much. Just we need to remember that the given values, so we have 18, which is A, and 107, and then 41. So B, so angle C is going to be angle B. Side A, so side B is going to be, so do it like this. Yeah, because those are the ones that we were finding. So we get B is 55. So just double check that. So we have 18. Let me just clear this. We have 180 minus, what is it? 18 plus 107, which we get is 55. Cool. Alright, I can trust that number. 55, an A. Okay. 15.466. So we have angle side. And then B is 47.865. 865. Next one. So we have angle, so we have side, angle, side. We want to use the law of sines to solve the triangle if possible. Okay. So this was for hashtag we have side angle. Now we need to solve for hashtag side angle side, which I think we already did, just without those values. So we'll use these values here. B is equal to, oh no, we can't because I don't have decimals implemented. Fun, we're doing this one by hand. Fuck. Alright. I have to implement decimals soon. Alright. Yeah, I can kind of just walk through the process, but we won't be able to actually do it with Quill. Because my dumbass hasn't implemented it yet. I don't feel like implementing it yet. Yeah, no, we don't do that here. We're still gonna try and actually solve it using Quill. Just it won't be the same exact problem. 0.7 B is equal to 25 and C is equal to 37. Actually, we don't need to run these as async functions. Doesn't really matter. We can just run them as normal functions. Solve for the triangle of. I want to make a programming language to code the code for the answers. Yes, that is correct. Because why not? Triangle of, this is SAS, side and side. You could take in the values of B, and C. Lowercase b and c are the sides, while the big B is the angle. So like if this was a triangle, right, you would have, I'm not sure if you guys will be able to see this, but I'll hold it up to the camera. So if this was a triangle, and the top was A, B, and C, we know that the angle here is 33.7. We don't know C and we don't know A, but we know that the C, side C, is equal to 37, and B is equal to 25, and we don't know A, or little a here. So this is, this is what we're solving for. So C So side C is directly across from angle C, so we know that this over here is side C. And then this would be B, side B, while angle B. So that's what the triangle would look like. And now we're just going to solve for the angle of angle C, which we have to do the inverse of. So this would be, because we have sine of B, so we do sine of B over B is equal to sine of C over C. Sine of B is 33.7. We don't know B, so we just write down B is equal to the sine of C. Oh wait, but we don't know C though. So we need to find angle C first. Oh no, we do know B, because B is 25. Yeah, no, I'm stupid. So sine of C, and then, yeah, so find angle C. B is 25, and then sine of C we'll leave alone because we don't know angle C, but we do know that C, side C, is 37. So we would have to use the inverse of sine when we finish this. Right? I believe so. Hold on. Let me just look through my notes here. Pretty sure we would have to do the inverse to find the angle. Yeah, we would have to do the inverse method to find the angle. Yeah, so we would just do everything normal. So then cross multiply 25 sine of C is equal to 37 sine of 33.7. We'd have to divide by 25. So sine of C is equal to 37 sine of 33.7 for 25. Then we have to do the inverse. Alright, so I think to do this logic on Quill, just open up some brackets here, open up the body of the function. So let's just do this quickly on the calculator. We're going to return degrees, so we need to make sure we're in degrees. Then we get the inverse of 37 sine 33.7 divided by 25. We get 55. 55.202. Okay, so I think in order to do this, let's do one without the 33.7 here. Let's see what we get. So we get 53. So if we do this correct, we should get 53.713 and so on and so forth. So, hello fishy, welcome to the stream. So, let's just call the function here. So solve for this, we would have B, which would be 33, 25, and 37. So let's say hashtag solve for angle C. So let's find angle C. Let's just say let's use lit. Angle C be equal to So we know that it needs to be the inverse sine, right? So we need to call the inverse sine, but we want it to be in degrees. So we need to call rad 2 degrees. We need to do the a sine of 37, which is C times the a sine of C times, we would do sine B, so sine of the degree to radians of b divided by the sine of radians 2 degrees of c. No. Here we would just divide by 25, which would be, yeah, so we just divide by 25, which 25 here is b. So in theory, let's trace this and say that the angle C is, and then we'll just call angle C. Granted, you don't really need to do this in the function. You can implement all your values like A and B. I just find it easier to just do it like this, for me at least. Probably making it a bit more complicated. And let as it. Oh no. We're not using the keyword of let. We're using have, and let's also comment that out. I had a brain fart there for a second. So we should get 58, which is not correct. That is definitely not right. Make sure that we're doing something right here. So we have B. So we have the a sine of C, right? It's because C is 37. Yeah, so C times the sine of B. Sine of B is 33. Divided by B, which B is 25. Can we info? No, we probably can't info that. Why did we get 58 here? Did I do my math wrong? I don't think I did. Did I do this already before? Let me check. Because I did this not on a while back, but I want to make sure. That's just if we have. Yeah, no. We do rad to degrees. We do the a sine of b times sine of a divided by a. Let me make sure I'm doing this problem right. So cross multiply, and we get b sine of c. So b sine of c is equal to sine of, or c sine of b. You need to divide by b. Get sine of c is equal to c sine of b divided by b. Since we're trying to find the angle, we need to do the inverse. Sine of b divided by b. So we would do the a sine, so the inverse of c, times the sine of b divided by b. Yeah, that's right. So did I do something wrong here? Let's see. So if c, let's actually just implement our values as well. So 37 b would be 33. Little b would be 5. We still get 58. So I wonder which one is wrong here. I don't think my calculator is wrong here. I think maybe my math is on that one. I don't know. That's odd. Why is that? Degree to radians. We should get a higher number typically if we don't. And we would get a lower number because this is in radians. So then we would need to convert this from radians to degrees. So then we would say rad to degree. Interesting. Okay, that's weird. Very weird. Alright, well, this is weird. Because I know my math is it's correct here. So because 37, we would have C times the sine of B divided by B. Yeah, divided by little b. Which is probably still going to return 58. Yeah, same number. Weird. Okay, I'm not too worried about it then. That is weird though. I wonder why that is. Hold on, I'm just fixing my OBS here. Wonder if I'm doing something wrong, maybe? I might be. Let me continue doing my math here, so I don't fail this. So angle C, which is the inverse here, so then sine of C would be 55.202. So 55.202. Angle A, since we have B and A, we can just do B plus A, or 180 minus B plus A. So do 180 minus A. Well, we don't know A. So we do B. Oh no, we only have. No, we would do C plus B minus 180 to find angle A. I'm stupid. It should be 33.7 plus 55.202. Let me just clear my calculator here. So then we would do 180 minus 33.7 plus 55.202. Get roughly 91.098. Alrighty, so now we need to find it's obtuse though, because we initially solved for angle C, and angle C is greater than all of this. So yeah, it's obtuse, which would be this function here. So if the calculated, okay, yeah, no, this makes sense now. Okay. So now we can say have now we need to solve #solve for angle A. So have angle A be equal to 180 minus B, big B, plus angle C. And then that should return the proper value. So now we need to check to see, or now we need to solve for side A. So hashtag solve for side A. Have side A be equal to. This one's pretty simple. Since we have all of our angles here. Where's my nice pen? So let's actually write down our values so I know what I'm doing. So we have 91.098. No, that's side A. We want angle A. 91 points. Where was it? Angle A is 91.098. Angle C is 55.202. Okay. So now we need to solve for side A, which would be, we can either use, let's use sine of B. So sine A over A is equal to sine B over B. Sine of A, which is 91.098 over A, is equal to sine of B, which B is 33.7 over B, which is then 25. Alright, so this we can keep as normal, and we don't need to do the A sign. So we kind of can steal our logic from up here to find the side, right? So we do we're using B here. So we would do A is equal to B, lowercase b, times the sine, times the sine of A, so we would have to call angle A, divided by the sine, by the way, degree to radians, of sine B, I believe, which B is a given value, yes. Right. Because of A times sine of B, we have to divide by sine B. Yeah, that's right. Okay. Let me change the music here. Sorry, something popped up on my YouTube. Alright. Let's change the music to different beats here. Alright, that should be more fun. Is equal to 25 times sine of 91.098 divided by sine of 33.7. That is way too loud. This one maybe? Hey yo, 60 subscribers. Nice! That's a cool one. Alright, so now let's grab our handy dandy calculator and do this math. Make sure we're in radians. Awesome. 25 sine of 91.098 divided by the sine of 33.7. That does not seem right. Oh, no. We need to do it in degrees because we have... I'm a dumbass. We need to solve it in degrees. Yeah, that makes more sense. 45. Because we're dealing with degrees, not radians. Oh, there we go. That felt good. Let me just actually fact check this with Mathway. If I can find where Mathway is, would be very nice. Alrighty, so we have 25 of sine 91.098 degrees divided by the sine of 33.7, right? Yeah, 33.7 degrees. And then let's find the exact value. Yeah, 45. Yeah, that's right. Okay, cool. Cool. Just needed to make sure about that. Wasn't sure if I did conversions correctly. So A is equal to 45.049. Right? Yeah. Cool. .049. What time is it? Oh, damn, it's already 8 o'clock. Fuck. Alright. Definitely not finishing all 30 questions. I definitely need to speed this up a bit. Alright. So... Okay. So is C greater than what we were given? Yes. So C is greater than what we were given. So... Alright. So now we need to determine if we have two triangles. So in order to do that, we needed to see if what we solved for, right? So hashtag now we check for two triangles. Alright. So using angle C, or if I remember correctly, the if statement that I wrote down in my notes for this is the calculated. So using the calculated, if the calculated is greater than the given, then we have two triangles. If it's not, then we only have one. So then we would only print the information for the first triangle. So now we would say that, should we use turn operation? No, let's not use a ternary operator. Ugh, can I English? So if angle C is greater than, let's use B, right? And I don't think we need to check, but let's just angle C. No, we should only need to check the angle because that's an angle, so we should only need to check the angles. If angle C is greater than B, then now we need to solve for angle, I'm pretty sure that the obtuse, so A would stay the same, and then what we solved for would be changed. So it was a given one in this one. So okay, so we do need to resolve for A, and we need to resolve for, so B is going to stay the same in this example, because B is the given, so the given would stay the same. Alright, where's my, so we can just automatically, so now we need to calculate the new angle B, find the new angle of C, so have obtuse, TUSE, angle C equal to, I think we just do 180 minus whatever our old value is. So we would do 180 minus angle C, which now that would give us our new angle. Right, and then we need to also find the new value for angle A. Let me just check my notes, make sure I'm thinking of this correctly. Yeah. Okay, yeah. So now we need to find angle A. Hashtag find the new angle for A. Angle A. Should we have obtuse angle of A be equal to 180 minus the obtuse, I'll make sure that's correct, obtuse angle of C plus B, and that should return our angle A. Alright, so we have A, B, and now we're solving for, so the given should be the same. So B and C should be the same. So then we just should have to solve for angle for side A. Thank you. Thank you, Fishy. Hope it does go well. So now we need to solve for the new angle of A. So have obtuse side A, side underscore A, be equal to, I check my notes, right? Alright, so let's do the logic here. So we have the logic, let's actually solve the given problem. That would be a good idea. If I can find the right page on. Okay, so we solve for C, so we do 180 minus C. So we have 180 minus 55.202. That would be 124. So our new angle would be 124.798. And since the B is given, we can just do the B plus the C minus 180. So 180 minus our new angle of C, which is 124.798 plus angle B, which is 33.7. That will give us angle A, which is 21.502. Cool. And then we would just solve for sine of B using our new values. So, or sine of A, or sine A. Ugh. Sine A. So we have sine of A, which our new A is, so lower B would stay the same because that's given. So we would have 25 times sine of the new A. So the new A would be 21.502 divided by the new sine of B, right? Or would B stay the same here? Because we didn't change B, so B would stay the same, so it would still be 33.7. So the only thing that's changing in this new calculation is the sine of A, so the obtuse angle of A. So we have 25, which 25 is B. So we would have B times the sine. We need to convert this to radians of the new angle, the new obtuse angle of A, right? Yeah. So obtuse angle A divided by the sine of degree to radians of mistaken? Yeah, B. And that will give us our value. Boom. Okay, and then we can just info all this information. So we say info, let's do trace. So since we have two triangles, we want to print out the original triangle, and then the triangle we have now. So let's do trace. Let's do angle A. So angle A, which is of type angle A, and then let's call angle B, right, which is now of just B, and then angle C, which is angle C, right? And this is for the acute. So we'll have a function saying trace acute. And we want to trace out the side. So side A is side of underscore A, and then side of B is going to be B, because those, and then also same for C. So side of C is going to be C because those are our given values. So then we're going to say trace the obtuse, and let's copy these two here, but we're going to change some values here. So instead of angle A, we're going to do obtuse angle A, obtuse angle A. B is going to stay the same because B is our given. We're going to do obtuse angle C. Obtuse angle C. I see a problem already. This needs to be lowercase. Then we're going to have obtuse side A. B is a given and C is a given, so those will remain the same. And then we'll just have an else statement saying just if. So if it isn't, then we will just print out the acute triangle here. Just like that. Get rid of that. Oh, we're not converting this 2 degrees. So we need to say the rad to degree of the inverse. Yeah. Boom. Alright, that should be all for that. So this should, I think, have 2 triangles. Just eyeballing those values. Yeah, so this definitely does have 2 triangles here. So we see angle A, angle B, angle C. So angle A, angle B, angle C, side A, side B, side C, which those are given values. Then we have our obtuse, angle A, angle B, yep, and angle C. Doom and doom. Yeah, that's right. Cool. So now we need to solve for side A on this one. These actual problems, since we don't have decimal points implemented, because we can't do 0.7, because that will throw an error. As we can see, because we have a cannot, with the misspelling, use dot operation without right hand being an identifier, which is a bit of a problem. I do have to somehow implement that, or remember to somehow implement that. When I have time not doing math homework. That should be relatively easy to add in, imagine. Knock on wood, because I'll probably eat my own words. 0.5 0.02 divided by the sine of 33.7. And we get 16. And that's so 16.515. Okay, next. Alright, state whether the given measurements determine 0, 1, or 2 triangles. So how many triangles does this possibly have? There's a way to check to see without doing any math. Let me see if I can find it in my notebook here. Because we have side, or we have side, angle, side, right? Yeah, so we would need to first solve for angle B. And then once we solve for angle B, we can determine if we have... Oh, okay, so this basically just implements what we did here. So this is all the same logic here, just with different numbers. So we have B, or A in this case, which would be 37. And then A, which would be B, and then C would stay the same, which would be 13. So we can actually use the function that we just made to determine there's only one triangle. Awesome. Why is this NA? Huh, that's weird. Wait a second. That's not correct. Hold up a second here. Why are those returning null values? Are they too big? Because we would have... Okay, hold on. Now I'm second guessing myself here. Wait, does this one do the same exact thing? No, we have bigger values here. This does A, B. So let's do A, which is 37, 6, and 13. Interesting. Huh. Okay, so now I'm curious. Why does it do that? And that looks really nice compared to the trace functions down here. They actually change those to, yeah, let's change these to info here. Control Alt down to here, here, and here. Info. No, we don't do that. We don't do that. I forgot to uncomment this line when we actually call the function itself. Interesting. Very interesting. Weird. But there is only one triangle. But now I'm second guessing myself. Hello again, fishy. Hello, hello, hello. Okay, now I'm second guessing myself. I'm actually gonna do the math by hand real quick. So we have... So we're just trying to determine, so let's just solve for sine of B. A over A is equal to sine of B over B. We have sine of, what is A? 37 over A, which is 6. And then sine of B, which what we are solving for here, is over B. We do not have B. Okay, so we need to use sine of C. Okay. So we need to then solve for C, because we can't solve for B because B is not a given value. Could we solve for B? No, because we don't have the angle of B. Okay, so we do need to solve for sine of C first. So, which is 13. And we get sine of C is equal to the inverse sine of 13 times sine of 37 divided by 6. And that would give us, let's see here. So let's do the inverse sine of 13 sine of 37 divided by 6. Nope, I forgot to close it off. What? Why can't I do that? I'm in degrees. Sine of 37 divided by 6. Yeah. Wait, so so then if you can't solve for sine of B or sine C, then there's no triangle then. What's the song? Send it to me. I'll play it, Launchy. Okay, if there has to be no triangle, then if we can't solve for for angle C, then there's no triangle, because every time it just errors out because we're doing the inverse sine. Yeah, so then there's no triangle if we can't do that. So whether given measurements, so 45, 8, and B. How many triangles does it have? 45, 8, 10. We do not have to write any of the logic here. And it looks like we have 2 triangles because we have the obtuse as well. So we have 2 triangles here. Believe it or not, as long as you have a sense of rhythm and can write good sentences, you can rap. Interesting. I mean, I would hope so at least. Alright, 2 triangles can be formed using the given measurements. The other measurement of the triangle, which angle B is acute, are also given. Solve the triangle in which angle B is obtuse. So for this triangle, angle B is 55, measurement of C, and the side of C is 11. Okay, so it did all the conversion for us. Okay, so let's use our function above here because this is a bit cleaner. Not gonna lie, it looks a bit cleaner. So we have 43. This takes in A and B. Okay. So we have 43, 8, and 10. Also, if you guys are curious, this is the Quill code for it here. Basically the same logic that we were doing, just written a bit differently. All the same logic though. So now, commented out that line. Awesome. Let's run this. Okay. So, yep. Okay. Cool. Cool. So now, consider the measure of angle B. So we're given A, so we need to solve for B, which is this. Which that would be 121.516 because we need a round. Angle C for the obtuse angle of C would be 15.484. Then the side of C, so A and B would stay the same. So C here would be 3.132. Easy. 10 more questions. We may actually be able to finish this. Awesome. Oh, mother. I hate story problems. You gotta be freaking kidding me. Okay, so we have 2 markers, A and B. Same side. The canyon rim are 57 feet long. So side C is 57 feet. Okay. So angle BAC. BAC. 27. And ABC is 58. Complete parts A and B. Find the distance between C and A. Huh. Okay, this is gonna be a fun one to try and figure out. Do I have a story problem written down for this already? Because I suck at story problems. Okay, I do have a similar one written down. except that it's given us the exact angles, which is not what we want here. Okay, so let's think about this here for a second. Let me. Okay, so it wants us to find the distance between B and C, or no, C to A. We know that the angle of BAC, so BAC, so this angle here is 67, and then ABC. Okay, I think we can. Okay, this is actually simpler than I thought it was. Alright. This is a bit simpler than I thought it was going to be, actually. Okay, so, just trying to think of how we can program this as well. Alright, so let's do the math first, and then we'll program it as well. We have 10 more questions, shouldn't be too bad. Hopefully, my math is actually correct. I'm pretty sure it is. I'm like 50% sure. So we have our triangle. We know that we have C, A, and B. We know that C, or side C, is 57 feet. And we know that angle A here is 67, because we go BAC, and then so we'll have this angle here, because this is our angle, which would be 67. Oh, cool, and there's no decimal point, so we can actually solve this, do this in Azura / Quill. Two names. I'm not sure on which one I want to name it yet, or which one I'm set on naming it. And B, so A, B, C is 58. Okay, so we need to solve. So we have little b, little a, and then we don't have no c. So we want to find the distance between c to a. So we need to find b here, but we don't have a. But A, B, C, B, C, A. Okay, hold on. Let me look back at that previous story problem I was looking at here. Wait, but we can find angle A or angle C because we know that we know what angle A and B are. So all we'd have to do is 180 minus our A plus our B to find our C. So it'd be 180 minus our A, which is 67, plus our B, which is 58. Get 180 minus that would be 67 plus 58, 125 minus 180 would equal 55. Big brains. Yes. Would be 55. Alright, so now we have angle C. So now we have a complete side. So now we can find B, because we have, so we can do sine of B over B is equal to the sine of C over C. We know we both have both values of sine of C. So we know sine of B, because sine of B, or angle B, is 58, because that's a given value, over B, is equal to the angle of C, which is 55, over C, which is 57. Alright, so now in Quill, so I'm going to copy the story problem and put this into a comments here. Control C, Control V. that is not correct. And I don't feel like typing all that out, but we may have to. Actually, no, we don't. We can actually just type out our values here. So let's first solve it, and then let's do it like that, because then we'll have actual values to base off of. Do it smarter. So then we have B is equal to 57 sine of 58 degrees divided by sine of 55 degrees. And that will give us our B. Or C, or technically our B is our C to our A. So make sure we're in degrees here, which we are. Okay. We would have 57 sine of 58 divided by our sine of 55. That would give us 59.011. Hold on. So if we have 55 plus 58 plus 67. Okay, yeah, that's correct. Cool. Just making sure that was correct. Alright, Ranchi, I'll play it. I'll play it just for the memes here. Let me pause this. I forgot how much I liked your music. Your music is super good. Or the beat to the music I like so far. I like that beat. That beat's really nice. Oh, I accidentally. Oh, that was funny. I accidentally went live on the old channel. That's a fun one. You know. All right. So we now know what B is, and it does not want us to round until the end, which is a slight problem here. Because now we need to find the distance between the two canyon rims, assume they are parallel. Wait, okay, so we found C to A, right? We know that C to A. Now it wants us to find the distance between the two canyons. So C, so the line straight through. Wouldn't we do we would cut it in half. Okay, I think I know how to do this. So alright, we found sine B. So we would have 59, okay. Now we need to cut our triangle in half because it wants us to find the distance from between the two canyons. So we need to go from C straight down to the middle. So that would then be a 90-degree angle. So we need to cut our length. So 57 divided by 2. That's, if I can, 57 divided by 2. 28.5. So we have C to A to B. Right? And we have B, and we know that A is 90, and B is still going to be, B is the same angle, so angle B would still be 58, A would be 90, so then we would do 90 plus 58 minus 180, we get 32. So angle C would be 32 degrees, right? Oh, nice. And now we need to solve for little b. So we can do sine of b is equal to b, or divided by b is equal to sine of c divided by c. So then we sine of 58, we don't know b, is equal to sine of c, which is 32, yep, over c, which is 28.5. So then we would do b is equal to 28.5 times sine of 58 divided by the sine of 32. Now b would be equal to, let's see here, so we have 28.5 sine of 58 divided by the sine of 32. We get 45. That looks right. Yeah. We get 45.61. Alright, so we have our two values. Let's do the math here to see if our values are correct. So, let's make a couple comments here. So, hashtag, we know that side C, so side C, is going to be equal to 57, right? Or A to B is 57. Or, so then we know that the angle of BAC is equal to 67 degrees, and that the angle of ABC is equal to 58, right? So now, let's create a new function, call it, we're just going to call it story problem. Story problem. Alright, this is going to take in a values of, we know we're going to take in value, we're going to take in A, angle B, and angle inside of C. So the first thing we need to do is find angle C, because we're already given our two first angles. So let's do have angle C is going to be equal to 180 minus our A plus our B, right? So then we would infill that, right? And then now we need, since we have our angle, we can now solve for the side of B to find our first given value. So now hashtag find the side B, or C to A, right? So have side underscore B be equal to, because that is a evaluation object, saying that is that equal to that, which is not what we want to do. And now since we know angle C, we can do the sine of B. Alright, so now we would have our C times the sine of B times the sine of degree 2 radians of B. B's are given, divided by our C, which would be 50 divided by our sine of C. Yeah, our sine of, and that's something we saw before. Yes, that is, because our sine of angle C. So we would just call it angle C. I'm pretty sure we would also need to say degree to radians. Alright, and we're missing one more. That's not right there. That's where we're missing it. There we go. Cool. Oh, is that the mistake we made up here? Ah, I see. That's the mistake we made up here too. We never closed off that parentheses there. Okay, that makes more sense now. So if we uncomment this, that's the problem we made. Okay. I see. So that's the problem we made in that code, was we never closed off our sign here to be different values. So we were running into that error. Alright, there we go. That fixes that issue. Right, so now we found our side B. Now we need to find the distance. So now we need to cut the triangle in half. So we need to reset A. So how can I write this? Because we need to now find the distance between the two canyons. So we can say if, we're just going to make a random if statement, if 1 is greater than 0, right? I don't know what we'd use for this if statement here, just check to see what we're doing for the math. Good. Is hurting like mother of pearl. Okay, so now we need to set A to be 90 degrees because we had to cut the triangle in half to find our side of B. Right, so now we need to say, let's use a const. Oh no we don't. We don't have to reset A because we can just define a new constant of A. So we can say const of A, or let's do let's call it, what should we call this value? Because it's a right triangle angle, right? So we need to define it as a new value. So let's do right triangle, I guess, because a right triangle has its base is 90 degrees, right? Triangle TRI angle is equal to 90. Let's do rad 2 degrees of 90 because that is 90 degrees. Alright, I don't think we need to do that. I think we can just define it as 90. We'll see. So now we need to now solve for the new values. So B is going to stay the same. So B is still going to be 58. So hashtag angle B will stay the same, right? So now we need to solve for angle C. Hashtag solve for the new angle of C. So that would just be, so have the new angle C would be equal to our 180 minus our B, because our B stayed the same. So our B minus our right triangle. Because our A is now our right triangle, which A would be 90. So now, right? So that should now give us our new value. Let's actually info this. So info will have, say that the C to A is, and we'll have angle C, right? And then now, we just wanted to say that the angle C is, and then now this console, this log here, the info C to A is, and then we would say side B. Go. Alright, now we want to log the info, so info, this is our new angle C, so we'll say new angle of C is going to be the new angle of C. We're just going to have another info saying now we need to find the distance from the we need to find the distance between the canyons. C-A-N-Y-O-N. Canyons. And we can actually move this line above this. And let's just add in a spacer, which is, this is just a space. Because I don't believe I support new lines yet. R/N, which I should probably add to. Add it to the things. True. Too bad. Okay, so now we solved for the new angle of C. Now we need to actually do the new calculations to find side B. So let's scroll down a bit so we can see what we're doing. Right, so hashtag now we find the distance between the value between the canyon, which should basically be the same logic as we have here. So we can copy this, paste this, and we're going to say the new side of B is equal to the C, because our C stays the same, right? Should be 28.5. Oh, it wouldn't be the new C because we need to take a normal C and split it down. So because we split it in half, so we need to say const side underscore C is going to be equal to our C divided by 2, and that should give us our value here. So we need to say side of C times our B, which is still 58 because our B stays the same, divided by the sine of our new angle of C. So this would be our new angle C. Cool, and then all we need to do now is console log info, say the distance between the canyon is, then we call it new side B. Cool. And let's see. So now we can call the story problem. Pass in our values, so we know that A is 67. B is 58. And side C is 57. So now, if we run this, please give us the right answers. Okay, so angle C is a value of 55. That is correct. We're just checking that here. Okay. Yeah, it is pretty slow. It's fun though. I love you're using your language, but I find it funny how much slower it is. Like how much slower it is to program the actual logic behind it. Or I assume that's what you're meaning. So angle C is 55. Yep. Okay. So now we need to solve for B, the original B, right? The C to A, which should be 59.011. That is correct. Okay. Yeah. Yep. Well, I'm doing it by hand too, just to make sure that I'm getting it all correct. But it is going pretty slow, but I'm finding it fun. This is C to A. Yes. Okay. This is just a space, so we can ignore that. Now we need to find the value of C. So the new angle of C, 212. Whoa, that is way wrong. But this is correct. Hold up a second. Okay, I did not do my math here correctly, I think. So new angle C should be 32. Oh, wait, but we're not converting it back to, that's the radians. That is, no, wait, hold up. I'm stupid. There we go. There we go. Now that's correct. Make sure you have your plus and minus signs correct. Oh, you called? Hold on. Let me... Let's see if he answers. Probably not. We'll see. Okay, and then 45. Yes, that's correct. 45.61. Because we're rounding. Also, Tyler, I did not see you called, so I am calling you back. Oh, hello.
Yo.
Going pretty slow, but it's fun.
That's funny. Yeah, I was like, I saw you streaming, and I'm like, what? Why can't I view it on here? And I'm like, what is this? And I started doing math, and I'm like, huh.
Yeah.
I mean, don't get me wrong. I actually, when, in Calc 1, I think I used Node for, like, as my calculator throughout the entire semester.
Nice.
And in class, other students were like, how are you computing stuff so quickly? Because there would be times when you're, like, learning limits or, like, derivatives, and it goes, when you're just learning the idea, they'll have you compute a crap ton of them just to see what happens around a value, for example. So they'd be like, compute 10 times f of x, where f of x is like 0.1, 0.01, 0.001, 0.0001, 0.00001, right? And you're like, damn, this sucks. And you can see how that could be done with a for loop really simply.
Yeah.
So, like, they'd be like, this 3 students calculate this one, you 3 calculate this one, you 3, right? And instead, it got to the point where at the end, I just used it, and he'd be like, okay, what do you have?
Yeah, that's, I showed my math teacher the original, because I'm just kind of redoing it, but just because I have to take a test on this on Wednesday, so I'm rewriting everything to make sure I actually have an understanding of it. But I showed I showed my teacher the original programming I did for it, and he was impressed. I used it in class, and I got the answer right every time, besides for decimal points, because my dumbass didn't add decimal points yet.
No, it's cool. Like, I think there is something. So I created to learn trig. You know what really got the idea down? I created a visualization in like JavaScript where I can move my cursor around,
Hmm.
and I also applied examples. Like I was like, okay, think about it. How useful trig is if you're trying to do graphic stuff, right? Like if you have a cursor and you want to shoot arrows ahead of the cursor.
Hmm.
I guess you haven't probably gotten to vectors yet, but anyway, if when you get to vectors in trig, which will be pretty soon, I would imagine,
Oh, I believe so.
then you'll be able to like predetermine where the position's going to be given a constant velocity of your mouse, right? You can like
Mm.
kind of try to aim ahead of it, and all it is using the inverse tan function. Like literally, tan inverse is like the most common function in graphics programming. Because you
Interesting.
usually know the x and y, but you don't know, or you know the angle when like maybe not the x or something like that, you know.
Hmm.
Anyway, yeah, but yeah, I find it really, even though it's slow as hell, I was like, I didn't know if I wanted to say anything because you will learn it really well by forcing yourself to pre-program it because it's different, than like,
Yeah.
so I respect it. It's smart.
Yeah, it's definitely different in the aspect that I actually have to understand what I'm writing down in order to convert what I handwrote to code, and then I just found it fun because I've already done a couple streams on Quill, which you've helped me with a lot too, which I do appreciate. Done a couple streams on it already. Just said fuck it, why not? Might as well do another one.
No, I mean, it makes sense. That's cool. Yeah. I was just here to see because I don't remember I'm not gonna lie. I was like, I know that like the formula for law of sines is way simpler than law of cosines. There's like law of sines is like sine A over B equals sine B over C, etc. Or
Yeah.
no, B over B, C over C.
Yep.
But like, yeah, I was like, interested to see
Yeah.
what problems you had for that stuff too.
Yeah, my teacher gave us the unit circle, which we talked about earlier.
Memorize that. Memorize it.
I'm going definitely to memorize that, and then you give us like
Be
a
like,
little
what is sine of
cheat sheet.
3 pi over 2? Right now, come on.
Alright, hold on, let me find it. I don't have them memorized yet, but 3 pi over 2. That's well the sine. So if we're looking for the sine, that would be -1, and it's angle 270.
Yeah, right, because you can say pi over 2 is up, so that's one 90-degree rotation. 2 pi over 2 is 180, aka pi, right?
Yep.
3 pi over 2, or like things like that. What is tan of what's a fun one? What is tan of 7 pi over 12, or like 7 pi over 6, something like that.
7 pi over 6. So the tangent. This is gonna be a fun one to do because I actually do math. Well, you said 7 pi over 6, right?
Yeah.
So it's gonna be a positive because the sine and cosine are both negatives. So I forgot how to. Here it is. So we'll just do sine over cosine, which let me grab my calculator. Would be on. So the sine would be sine over cosine. So I have -1 divided by 2. That's not right. Negative.
So
1 divided by 2 divided by negative.
don't forget they're mirrored images. So the third quadrant, you would agree that sine of 7 pi over 6 is the value in the third quadrant.
Yeah.
Right? Because the first quadrant is anything from 0 to pi, or 3 pi over 6, right?
Yeah.
AKA pi over 2, right?
Yeah.
Or 0 to pi is the same as 6 pi over 6, right? So that's quadrant 2. But if you were to look at the unit circle, only memorize the first quadrant. Everything else is either a reflection or an inverse, right?
Yeah.
So think about it. Pi over 6 is root 3 over 2, right? You could use like 36, 30, 45, whatever it is, right? And 1/2, because you know it's 1/2 the way up, and it's root 3 over 2, like 0.86, whatever, to the x, right?
Yeah.
You could say, well, isn't it the same distance to the left as it is to the right in the same down, right? Everything's negative instead.
Yeah.
So if you know what pi over 6 is, and you know that 6 pi over 6 takes you to pi, right? Then you can just say, okay, what is the equivalent thing? Oh, it's root 3 over 2. So if I know I'm in quadrant 3, I just negative it, right?
Yeah.
Because you know you go to the left root 3 over 2 and down, negative 1/2, right? And then that'll kind of give you the sign, right? And if you know the sign, you can find the cosine. Or and I think that's tangent, but
Yeah, you
with
did ask the tangent.
yeah, that's tangent. So you'd say, okay, it's negative 1 over 2 divided by, right?
Yeah, the negative
Negative
root 3 divided
3
by 2.
over 2. But to divide, you can multiply by the reciprocal. And so you have negative 1 times 2 divided by 2 times that, right? And then that gives you, well, it's negative root 3 over 2.
Yeah, because we needed to get the root out of the denominator. So then we would have to,
Oh, your teacher really anal about, like, making sure there's no square roots in the denominator.
Yeah.
That's sad.
I have to study my unit circle a bit more, but
it's fine. I just wanted to throw that. So if you, like, those are the kind of things. So like in calc, you won't need to know like really weird angles. I feel like we very rarely see them, but like knowing how to quickly like, if you can memorize just the unit circle, just the common ones, right? So memorize all the ones in the first quadrant and just know where they are. It'll be so simple. There's kids in calc who probably don't know it and are fine, but imagine if you did, right? And they don't have to look at the stuff. You can zoom through homework.
Gotcha. Wait, so is this asking for here to here and here to here? Okay, the platform is about. Okay.
Oh wait, question. What are you using for your overhead mic, or not mic, overhead camera? I've been wanting to create some math videos for my friend. He wants to know how to do like discrete structures homework.
Okay.
And I love that kind of stuff. And I wanted to get an overhead camera, but like,
so
it's expensive.
The camera I'm using right now, so I have two cameras. I have this camera, and then I have another camera that will show a different angle, which is this camera here, if it will turn on. But it doesn't want to because I've had my PC on for too long. But the camera I'm using for the overhead is a, I'll send you the name of it because I have no clue if I will butcher the spelling of that or the name of that. So,
Is it just are you using a camera and some sort of like tripod or like some like, how are you mounting?
Oh, so I have a, I have a loft bed pretty much. So I'm just using the underside of the loft bed, and there's these little rivets, and I just stick it in there. It holds it pretty well. It's really jank, but it works.
I mean, it makes sense. Yeah, I'm over here like, dude, I have my desk, and I want to set up a camera that goes overhead. Hell, I don't even care if I have to use my phone.
Yeah.
But
615.
they're expensive, and I'm like, I don't want a tripod and have to like do some weird janky like, like. You know, like trying to lay a tripod horizontally 90 degrees or something.
Yep.
Fun. Are you ever going to add for your language a ability to just log the value instead of the actual like object itself? Like so info? Like so you know your info of like 45. If you did info of 45, you would get an object containing value 45 type number, right?
Yeah.
But I would set it up so you can just get the actual value.
Yeah, so I have one that does that already. I can actually show you. So if I do trace.
Oh. Okay. So info is like a more debuggy function.
Yep. Because if I do trace, you see that trace only just prints out the 45, and then you also have. Oh, you have stream delay though. That's not. Oh, my bad. I forgot about that.
It's not too delayed, I think.
It should be like 10, maybe 5 seconds. But if we just trace 45, it will just give us 45. Which is nice. So this is asking for the distance of this length, so A to B, and then, so A, B, C, and then C to B. Fun. So let's label A, B, and C. Let's find angle B. I love math, but I hate math at the same time.
Oh, this is like bullshit math. No one likes trig. Like, there's something about none of these problems are fun or have any application. And so I feel like vectors, I guess. They have application because they build.
Yeah. I mean,
But,
vectors, at least you can use them for, like, game development and stuff like that, so there's some purpose to it.
Vectors in trig are the only ones where you don't need to learn other advanced math to use the trig. Like, the identities, oh my god, they're so freaking annoying when you're taking trig. Because you're like,
Tell me about that.
when am I going to need to translate sine of, secant cubes this times secant squared invert of this, right? And you're like, how? Why? Why do I need to know these?
Yeah.
But they will come up in Calc 3, they'll come up a lot because of three-dimensional space, and you deal with, like, parametric equations. I don't know, are you going to learn parametric equations in trig, too?
I don't know.
Usually, okay.
Because I'm in pre-cal right now, so depends on how much my teacher wants to actually teach us.
Yeah, because wait, pre-calc. So if you're in high school, pre-calc, I would imagine would include, like, what it was the algebra you started at, like,
So
algebra for pre-calc.
my freshman year, I started in algebra 1. Then sophomore year, I went to geometry. Then my junior year, I went to algebra 2 honors, and then now I'm in pre-cal. But
Interesting. Do they not just have a trig thing?
I don't know. I never really looked into it that much because I was just going off of whatever classes I needed to graduate. But I think they do. I know they have a calculus 1.
Yeah, they probably have AP Calc, I would imagine. AP Calc A and B.
Yeah.
I mean, even C. I don't know. Very few high schools I feel like have a Calc 3.
No, I think we have 1 and 2 for calc, and then I don't know if we have trig though. That's something I will have to see. I believe we might.
But I was gonna say the parametric equations, they're kind of cool. You can use if you do anything with game dev. Trig is, like, actually probably the most important math you'll ever take.
Yeah, no. So I did a bit of game development when I first started programming, and there was a lot of trig. So
yeah,
I learned a lot of the fundamentals a bit earlier on, so I have a decent understanding of some of the concepts at least.
No, that's good. I think yeah, like, people will talk about, like, I say this, if people, like, my professor said, like, first day or, like, second day of class, he's like, students don't fail calculus because they the calculus is actually really easy. They fail it because of algebra and trig.
Yeah.
If, like, literally, I kid you not, if I were to just take any problem, really, like, let's just say an integral or derivative or, like, things like that, right? Those problems boil down to, like, the first few steps being or calculus. And they're not even hard steps. Like, there's maybe a little more memorization, I would say, like, rules. But once you memorize these rules, it's just like, do you know how to simplify this algebraic jumble of crap into something that, like, is usable,
Yeah.
So that's why I was saying, like, just, and no one likes trig. I didn't like trig. Just this, I guarantee you'll never need to use this stuff again, though, maybe.
I probably would never have to use this ever again, but
this problem, like,
this is a little
sines, cosines. Maybe there's a few problems in, like, Calc 3 where we use that. I don't know.
I gotcha. Yeah, I never see myself having to ever use law of sines or cosines. Like, when do I mean, granted, if I'm trying to find, let's say in game development, if I have to calculate a triangle, then maybe. But
it's a weird one. I mean, I guess they have to teach it to you because maybe some of those students will go on to be engineers, and then they'll go into differential equations and things like that. I'm sure. I don't know.
Oh no, I want to do sine of b is divided by b over sine of
Funny, I don't remember how to do this. I know the formula, and I'm over here like, what the fuck is everything? So A would be, let's say A is 72, B is 82, and C is the platform. So that means A is the side opposite of 77. B is the side of that. Oh, so C. Okay, I get it now.
Yeah.
I was like, where do you find the little C? Right?
So I did mine a bit backwards. I started off with 82 being my A, and then the platform being B, and then 77 being C. Just
So
went in that order.
know, yeah. So you can know that you know what A is, or you know what B is. You know what big B is. You know what big A is, which means all you need to do is find little a.
Little C and little A.
Oh, I guess you had to find both of them, but yeah, so it's
Yeah.
not in that case.
Well, it's also asking for, so the platform is about, it's asking for the little, this would be little c, so it's asking for little c, and it's also asking for little a as well, which is irritating as hell, but, I mean, it is what it is.
Have you done law of cosines?
Yes, actually, I've already written the logic for it a while back, which is here.
Okay.
I haven't had to do law of cosines yet on this test, so I'm kind of worried that's gonna pop up soon, because this was a pain to, not really, it wasn't hard to figure out, but implementing the formula was a bit of a pain to try and figure out how to do.
Oh god, if I had to remember it off the top of my head, it would probably be like, it's c squared equals a. Wait, it's sent with like a and b, the lower case now. So it's like big angle c is equal to side a. Oh no, side a times 2 times side b minus. No, oh no, it's squared. Yeah, I remember.
You're right to begin with.
It's big angle c is equal to b or a squared times b or plus b squared minus 2 times a little c times cosine of big. I have no fucking cosine inverse of c. I don't know.
No, so if you're trying to find the so when you're doing the law of cosines, if you want to find
because it's good when you know the sides instead of the angles.
Yes.
And you want to know a big angle. Yeah.
Yeah, so if we're solving for the side, so if we're solving for c, right, it would be c squared is equal to a squared plus b squared minus 2 times a times b, and then you would also have to times the cosine of big C, which...
I was close. I got the a squared plus b squared minus. Oh, it's just cosine of... Wait, what's omega? Is that omega? What the fuck? Gamma. Ugh, I hate Greek.
Gotta love it.
Why do you use theta, and then in the next question you're like, oh, it's time to throw in some...
weird values. Yeah.
Kind of... like... angle opposite of C. Okay, it's big C. Why not just say big C? Yeah, law of cosines.
Gotta love it. The best was trying to or not implement, but the easiest one, I think, in my opinion, was when you have just the sides and trying to find the sides, because that was super easy.
Wait, just the sides?
So like,
wait, what?
So if it just give you the sides, right? So it's really easy, because all you have to do is first you need to see if the triangle actually exists. So you do your your A and B.
It could be there's 3 different forms. You can have an indeterminate form, a 2 triangles, or 1. I think.
Well, no,
because there's a way
for law of cosines, there's only ever 1 triangle. For the law of sines, you can either have 2 or 1 triangle.
You can have 3. There's a chance it could be undefined.
Really? Huh.
Yeah, you can think of how if 2 sides, if their lengths are really large, the third side has to have a abnormally large length, which means it could be an unclosed triangle.
Interesting. Okay.
Because there's 2 possibilities for those angles in which branch they go. So both of those angles, that means that there's the one unknown side, right? There's a possibility for a law of, what is it? Law of cosines? Unknown. No, I don't want that. Invalid triangle. Is it law of sines or cosines? One of the 2. But there's a way, using law of sines can result in an invalid answer. Yeah, so there is a way for the law of cosines to produce a completely invalid triangle.
Interesting.
You would know because the value would be... I forgot how you test... In fact, I have no remembrance of how you'd even test it. I would fail if I had to take this right now.
Well, Well, I know to see if there's actually a triangle, you need to add the, let's say, like A and B together, and if A and B is greater than C, and then you just do that for all the cases, so that if all of them are greater than whatever the value that you're testing it against, then there's a triangle there, so then you would calculate all the angles. But if it isn't, if one is less than the other, then there's no triangle at all. I know that, at least.
Yeah. Oh, here we go. It's the ambiguous case. So yeah, here's a good example. This is actually a good little graphic. I like this.
Let me see.
Send this to you on Discord. It's this website. It looks like it has some good little graphics. I kind of like this. Yoshi Yara Books. But it's section. It's like a little bit after the top, so it's probably like 20% in. It's using the law of cosines for the ambiguous case, and it can show you like if A is less than B in the angle of, is less than B times sine, alpha or like omega, things like that. But it can show you how how there's two solutions, right? Because they're equidistant and it's possible to have that.
Yeah.
One solution and then no solutions. So it's using the law of cosines for the ambiguous case, if you find that section.
Yeah, I found it. Yeah. Interesting. Okay.
Interesting, yeah. Huh. Law of cosines.
I did not learn about that. Not yet, at least. Probably learn about it. Nope, I won't be there at school because I have states this week. Fun.
What do you compete in?
I wrestle.
Ah.
Yeah.
It's fun.
No.
No?
No.
People like what sport they're in.
No, I like it. It's just, what's the word? Stressful.
You're like, I like the wrestling part. I just don't like the getting my face smashed into the mat part.
Yeah. Yeah. So we need to solve the triangle. We're given B, A, and C. So we need to find angle A, angle B, and angle C. Oh, so this is just side, angle, side, which we already calculated down here. This is side. This is angle, angle, side. This is side, angle, side. Boom. So we can actually just reuse this and say that our angle, which is B, which our angle here would technically be C. So we have 98, 4, and then 6. I think we can now run that.
Oh yeah, you can see our multiple choice questions does have the no possible solutions.
Yeah. Okay. Oh, mother. No, okay. So, why is this... Now, I haven't been able to figure this out yet, but sometimes if the numbers... Well, return a value of NA and NA, and I don't know why, so now I'm curious to see if there is no triangle. Sorry, fill in the answers, the boxes, choice, do not...
Well, let's see. It says the angle... Okay, so we can test this kind of. We can say, okay,
Yeah.
if that length is 4, the angle between them, so angle B, or I guess we already know the name is C, so angle C is 98, and that is 6. That means the angle that needs to join, because it's larger than 90 degrees, the angle that needs to join back with B, right, has to be large. It has to be larger than that, too.
Yeah.
So... what do you get as the output? If you get undefined, I'm sure that it probably doesn't exist.
Well, no, it returns a value of NaN, which...
Yeah, so I'm
if
sure. What's the logic you do? So off to acute else B times sine of that divided by sine of that. So I don't say divide by 0. Interesting. Angle A. Well, yeah, I guess that it does make sense. If it's not a number, one of those can't be computed, which means you probably can't compute the other one.
Yeah.
Yeah. I would confidently take the guess, but I have no clue how to double check it, so I don't. you know, like I don't know how to algebraically check it. I don't remember that.
Yeah. I mean, okay. I'm gonna mark it because I would assume there would be no triangle if it's returning NaN, but I don't trust my own code, so I'm gonna do it by.
You don't trust your programming language code or the code that your programming language implements it in?
Both.
I know, it's like, not only do you have to trust the code you're writing for the problem, you have to trust the language to implement it properly.
Yeah, so I don't trust both. So, let's find... So... Oh, wait. So if we have side angle side, we first need to find... Okay, this is going to be tricky. Because it doesn't give us 3 values here.
I mean, you can use... Here's what I would do. I remember how to do it. Okay, I remember what you need to do. God, it's all coming back. So, use your law of cosines. So, set up to find A, let's just say. Let's just say we're going to find A.
Okay.
Use your law of cosines where A squared, so 36 plus 16 minus 2 times 4 times 6, right?
Plus B
Times cosine of A, which means if you
it would be cosine of C because we're solving for
cosine of C, yeah, and then
oh no.
Well, no, but we want to solve for an unknown, so we do actually want to do.
Yeah. So.
Oh no, we do C. Yeah, you're right.
Yeah.
So it's C equals.
Because it would be C squared.
Yeah.
Is equal to A squared plus B squared minus 2 times the A times the B times the cosine of C. If I can spell cosine correctly.
No, the issue is that still doesn't find any unknown.
Well, it's because, the problem is because I was trying to use law of sines to find a triangle that uses the law of cosines, which is why it's returning the value of unknown. So, I think let's just, program this.
So it'd be. I mean, what the issue is though, is it lowercase c?
Yeah. So we're trying to find lowercase c in this instance because big C is given.
I didn't know if the
which
formula
is
has c or uppercase, lowercase.
Yeah.
Because there are some formulas in trig where like it literally just you don't get any unknown, but you can rearrange it right to find something.
Mm-hmm.
And I didn't know if this was one. I don't remember if this was one. I know there's a lot of vector ones that are like that. It's like what vector method is it? It's the dot product. I know cross product. Where like there's like 5 different ways to solve for the cross product. One of them if you know the magnitude, one of them maybe if you know what the theta is, if you know what the dot product is, you can solve it that way. And so like one formula can be used tons of different ways.
So we want to take the square we want to take the square root. Then we want to say that
you want to take the square root.
How we want to take an A and the value of 2 plus how I need to rewrite a bunch of the backend code so you could just do b.pow or a.pow and just put it to the power of 2 instead of doing it like this.
Oh, like star. Yeah, implementing star. I mean, think about it though. Star is just a binary operator.
Yeah. Oh yeah, no, you're
so,
right.
If you already know how to handle plus, minus, divide, exponentiate, is just one of those. It's just a 2-character operator. So in the Lexer, if you find a star and you find a following star by peeking ahead one, then you can actually build a exponentiation operator instead of just a star operator. Just like if you find a plus and then you look ahead and you find an equal, you actually do a plus equal operator instead of a plus operator.
Interesting. Okay. I will have to implement that then.
Yeah, I mean, like implementing that in numbers, I find pretty simple. It's just you got to think through the cases, right? Like if you have plus, you can't just eat it right away. You have to double check that there's not a following equals, right?
Yeah.
Or divide, same thing, star. But for numbers, it's interesting, right? Because you already know how to parse a number, so all you have to do is just keep track of if you found a decimal while parsing the number. If you haven't, then if you find a decimal, you set the flag to true, and you keep parsing it, right?
Yeah.
If you find two decimals, then you throw an error and say, hey, bro, what is this? It's not a number.
Yeah. So,
And if the number starts with a decimal, you just add a 0 in front of it, an implicit 0. If you want to allow that, some languages don't allow dot, like you can't just type let x equal dot this, which makes sense. It's kind of weird.
yeah.
You would rather you force them to do 0 dot. So you can say, hey, if it's a dot followed by a number in the lexer, you can throw an error saying, hey, did you mean to add a 0, right?
Yeah. So 2 times 6 is 12. 12 times 4 is 48. Yeah, that makes yeah, I have to decide on that. I don't know.
It's always usually a good idea to not let to force a user to add a 0 before the decimal. Because if not, then it might get confusing with number expressions, right? Like if you did foo dot.
Oh yeah, true.
5 or something, it's just weird, right? So,
cancel that further. So now we take the square root. Yeah.
You can do what JavaScript does and have numbers separated by underscores, so that way you can handle places that way, right? Like you can do, say you want the number 10,000, you can do 10 underscore 000 in JavaScript, or the number 10,000, right?
Yeah.
So there's those kind of there's a lot of little things you can do. Like you can say, yeah, but then for the number parser, you'd have to pattern match that, like there's properly 3 spaced, and then like that, but you can make it fancy. There's so much little syntactic things. Like it's kind of crazy to think if you want to implement everything that your favorite language does, how much you'd really have to do.
Yeah. Cool thing is though, that logic is correct first try. I'm surprised. 6 6 0. Yeah, there's I still have to finish adding in the member expressions for the because we fixed the strings earlier. I still have to do the numbers, and what was the other one? It was the numbers, arrays, and function, I believe.
But you can see how this is literally identical. It's just instead of a string lookup table, you'll be using a number lookup table. Instead of using a function or a string lookup table, you'll be using a function lookup table, which, don't get me wrong, function probably won't have many static functions associated with it, right? Think about it. Like, what does function even have? Maybe it'll have the ability to get the prototype, which might be like the declaration, or like toString, which will actually return the string representation of the function, and maybe a call field. Which just calls it. I don't know why you'd want that, but that'll bring you into classes easily.
Yeah.
So maybe call isn't useful, but the prototype field, if you have a function, you can make a function a class, basically. Like most people don't know, but JavaScript classes aren't actually, they're just functions under the hood.
Interesting.
Yeah. Some people don't know that, but you can implement every class feature as a function in JavaScript, because before 2016, they weren't classes.
What were they before?
You used functions to create your classes. It looked the same syntactically to use it. So you do like foo.this, foo.private, foo.public, right? Like, but there was no such thing as class keyword. There was no constructor keyword. There was no private, public. There was none of that. You had to implement everything using closures, which is what a class is. I mean, really.
Yeah.
A class is just a closure around some variables. Some are returned and some aren't.
Interesting.
Yeah.
Oh, this is gonna suck to implement.
Law of cosine C A B.
Because now we need to find the angle of A, and that's gonna be a bitch. Okay.
Well, not necessarily. Think about it. You know what C is. You know what B and A are, right? So, couldn't you just use the law of cosines with A, given that now you know what every side is?
Yeah.
Right, so like, what is that? So what do we have as knowns? We know little c, we know all 3 sides and an angle, which means if we know, what is it? I'm sure it was like, we could also use the law of
Minus it.
we can use the law of signs to find A.
Yeah, we can.
We have little c and c and an A.
Yeah, we do.
So we can say angle A is equal to sine of 98 degrees times 6 divided by whatever c is. So to rewrite that, it'd be A is equal to sine of c times A. That's the times A is on the outside of the sine function.
Yeah.
Divided by c.
Yeah, so it would be because we already know what A is.
Little a, yeah. We can just do do sine of c, big C.
Yeah, which would be
whatever that result is. Multiply it by little a, and divide all of that by c.
Which we would just call c.
Yeah. So type in sine of big C,
which is right there, because we taken c as a value, which is 98, and then we should just be able to info
C.
A.
Yeah, you want all of it in radians. I would add that so language. I guess maybe, but I would always make it so your language takes in radians by default.
It does take in radians by default, or at least it should. I'm pretty sure it does.
And don't forget to wrap the parentheses matter here for sure. Actually, I guess it doesn't since it's all multiplied.
Yeah, I mean,
it doesn't matter in this case since it's multiplied.
Yeah.
There we go. And that is that.
So we should get 44. Let me check the math just to be. I mean, 44. Okay, so actually we can check this easily to see, because since we have angle A and we have angle C, we can add those to find angle B. And if those are equal to 180, then we know that we did it right.
Yeah.
So now we can see.
Well, not per se. If it doesn't add up to 20, it could mean it's an indeterminate form.
True. How do I do it before? That's for side to side. It's for the area. Okay.
Can you find the area? I don't remember what the formula for area is. It's like 1/2 pi r squared. Oh, is it 1/2 pi r squared?
Yeah, I think it is. It should be. No, it's 1/2 times A times B times the sine of C, or whatever you're trying to find. So that one would be sine of C, and then it would be A times C, sine of B.
Oh yeah, because you don't know what R is, and you.
Yeah, you need to find R.
Find it. Yeah, that'd just be it, because then you have to convert. Yeah, you can. Yeah, it was like. After I start thinking about it, like, wait, this isn't a right triangle. How in the hell can you find R?
Yeah. Yeah, no, okay, yeah, no. So this is correct. I'm looking at an older function of where I of how I did it before. And that is, yeah. Okay. And then just to find angle B, we would just have B be equal to 180 minus R A plus R big C. And that's just info.
You could also, you know what would be a cool feature to add to your programming language as a built-in? In fact, this is something that I'm working on adding into mine. I'm trying to add it so users can write mathematical expressions, and it'll simplify and find roots and derivatives, integrals really easily.
Interesting.
So there's a library that you should take inspiration from called math.js. Very original, I know.
Oh yeah.
But this library is super cool. For calculus, it's also cool because you can double check your work through code really easily. This is basically
nice.
what I guarantee you. This library. Oh, I put it in that trunk chat. This library is probably what sites like Mathway and like things like that use, like under the hood, whatever the language's equivalent is. Because it allows you to take in a string like x times x, right, or x caret x, or x caret 2, right, for x squared, and then you can do simplify, and it'll give you. Well, in that case, it probably won't give you anything, but you could then take derivative, right? And if you know what a derivative is, you know the derivative of x squared is 2x.
Yeah.
And it's really cool. It'll give you that. So
Interesting.
you can, if you imagine if you implemented a method like this, what's awesome is you can actually, since this is written in JavaScript, you can actually just use this for your language here.
Hey, that would be
But if you did it in C, you'd have to then implement a mathematical parser, right?
Yeah.
And AST. So to actually implement this so you're using your own kind of stuff, you'd have to write a parser for mathematical expressions. So instead of writing a parser or a language, quote unquote, right? For this, instead you write a language which allows things like x caret 2 for meaning like x squared, right? And you'd have to understand how to take that node and translate it into, like, I don't know, it's kind of cool.
Yeah, it definitely is.
Doing the derivative is like the hardest thing I've ever done in my life.
Yeah.
That.
559.
But I give ideas because I've always wanted to input. I don't know if how reasonable it'd be or how hard it'd be to modify a language. It's like a lot of work, but making it so your built-in language could just, no need for a string. Imagine if you could just type in let x equal, like, kind of like regex. You notice how you don't have to put it in a string in JavaScript?
Yeah.
Regexes? You can just put it in and it's like understood that it's regex. Imagine if instead of regex, you can do it for programming, like math stuff. So you could type in x caret 2, and that'd be x squared, and it would just do it for you.
That would be that. Okay, I'm definitely kind of contemplating adding this in now.
Because then you wouldn't have to do x exponentiation operator too, right? You can just copy a problem from like this, put it in your code without having to modify the symbols or anything, you know?
Yeah.
Or like, I don't know. I debated if I wanted to add like things like that because I think it'd be kind of cool, but maybe it's not feasible. I mean, if data science languages like R don't have it, then I'm sure there's a reason.
Yeah, I'm sure though it should be possible.
Yeah. Oh, I would imagine if you make a really specific language for that feature, it'd be pretty possible. I'm just wondering how much of the other operations it might hurt if you like add that operator, right? Like, I don't know.
Yeah. Right.
Math.js. But yeah, if you ever wanted, you can use Math.js to like implement, right? You can create a derivative function. Use that in your language since it's written in JavaScript and just get the derivative of something really cleanly and really easily.
I'm contemplating just stealing the code that I already wrote and just copying and pasting it down because it's basically the same logic. I'll explain it as I paste it. So basically, to find the angle, because we're only given the sides, so we need to do, obviously, the law of cosines of the sides outside, so we need to use the same formula we were using before, but since we're trying to find the inverse cosine of A, right, we would then do the same logic, but it would be the B squared plus the C squared minus the A squared divided by 2 times B times C, and that would give us our A, and then I'm pretty sure for the B, it would be pretty much the same logic, just A, C, and minus the B squared, I believe. Yeah, I think so. That's to find angle B. It would be basically the same logic, except we're trying to find, don't need this comma.
Holy shit, I'm having an aneurysm looking at that if statement.
Just looking at this one?
Yeah, I'm like, what does that mean?
Yeah, it's just basically checking to see if there is actually a triangle there.
Yeah, no, it makes sense.
Yeah, we can probably write this with a ternary operator a bit easier. Who knows though?
I don't know. I like ternaries for really simple, like this or that. Like if something's undefined,
yeah,
like
so like
DB calls, right? Return something. If you have to return that it succeeded or failed off a DB call, you can just like really easily do a ternary. Everything else I don't like ternaries because I find that like I'll eventually need to like add a console log or something, and then I had to like add an if else anyway.
Yeah, so this is a way that you would define a ternary, and
Oh yeah, how do you do yours and yours?
X be equal to 0. So there's a keyword called turn, because I'm lazy. Just set it to a keyword. Probably shouldn't do that though. So I'll probably end up fixing that in the long run, but this is just basically how you do. Same kind of logic for other ternaries, with the question mark being your if, and then the colon being your else.
Where's the turn keyword? I don't see it.
It's at the very beginning on 504. Let me screen share so it's a bit easier to.
Wait, what? Oh, the streams. I see.
Yeah,
I'm not looking at that. Okay.
There we go. This is probably easier.
Oh, yeah, the stream wasn't caught up. I'm like, what are you talking about? There's only 500 lines in the file.
Yeah.
Oh, yeah. So you do turn. Oh.
Yeah.
So if you were to do return, you'd have to do return turn of x equal 1. Huh. Why not just not do the ternary keyword?
Because I was trying to figure out how to not use the turn word, and I couldn't really. I somewhat got it working, but at the same time it wasn't working, so I just decided to slap on a ternary keyword and leave it there.
Well, okay, I'll give you a hint, because this is something that I never talked about, because all of your language up till now is a one look ahead, or is a no look ahead language, right?
Yeah.
It means you can peek, and what that really means is you're peeking at the current token, right?
Mm.
There is languages which are recursive descent which have look aheads, so more than one. It means you can look not only at like the X in that, you can compute stuff, and then once it's computed, look ahead. And that would be how you'd have to implement a ternary properly. Where you've computed the comparison expression, right?
Mm.
And add it when you're in the comparison expression, you would have to compute it. But the issue is you want it to work for any type of expression, right? You want to just identify anything. So what you'd have is at the top level of an expression, right? Because expressions evaluate something. You would look ahead again for ternaries or things like that. There's not many look aheads that need that kind of like extra look ahead. Ternaries, I think, and I can't even think of another one that needs it. I'm trying to think. Yeah, ternaries are like the most complex operator to implement.
Gotcha.
X colon equal, yeah.
Nice.
Brace and have. Did you implement your own extension to get highlighting?
No, this is just CoffeeScript highlighting.
Oh, I was like, damn, you went above and beyond and actually implemented some highlighting. It looks good.
I want to. Eventually, I want to kind of modify, because there's some things that I don't really like about CoffeeScript with the way it looks. Because like instead of doing like an else if, right? I like the way Python does it with an elif statement, but the elif statement isn't highlighted. So I would eventually down the line, once I figure out how to do that, make it so that the elif is highlighted as the same color as the if and else statements as well.
And then you can create a language server.
Oh God, that won't be fun.
Or you can get some IntelliSense, and you can type the word and get some hints.
Yeah, because that will definitely be needed.
Oh, that'll be the hardest thing you'll implement. That'll be harder than the language, I guarantee you. I'm just gonna say that now. If you wanted to implement a language server for your language, that is anything more than like just super basic. You're gonna have to like. It'll just not be fun. I'm just gonna say that now. The reason I know is because I implemented the most crude language server for just a really crude language, and oh my god, it was hard. It's just a lot that you have to consider.
I got you. Yeah.
But it's cool to have IntelliSense for your little language.
Yeah, instead of guessing it and not being correct and all that fun stuff.
Yeah, so you could type math, and it'll know because it has the AST in memory, right? It'll know what it has to give it. So it's kind of cool. Yeah.
1, 0. Yeah. I definitely want to eventually do IntelliSense, but that will be very, very, very far down the rabbit hole.
Yeah, there's just so much, Tim.
Yeah. 5, 2. I don't know what it is too. I just, like we were talking about earlier, I just found it. I find it so much fun to just to see and make something from scratch and have it solve the triangle. Oh, one of these again. I fucking hate these. But just to like see something that you make from scratch then turn into something like this. I don't know.
Yeah. That makes sense.
Do appreciate those videos you made on it too. They definitely were helpful to get started.
Yeah, I think building a programming language, even if you're never gonna actually use it for some stuff, it really helps you with other programming languages. Like, if you know how a language is implemented, you can read errors better, you can understand syntax errors better, and you can understand like logic because you know like, oh, I know that this under the hood is what's kind of giving me this error message. So it helps you kind of debug code yourself a bit.
Which is nice.
Oh, for sure. I mean, if you're writing some C stuff and you understand how like certain precedences and operations are handled, you can really quickly get to the root quicker than somebody who maybe is at your same level of C skill or something, but just is like doesn't know how expressions, right? Because you under the hood understand like why order of operations. How does order of operations really get handled, right?
Yeah.
It is because of the AST. That's it. So you can understand how like if you were to look at any language's code, you can kind of piece together how their AST is getting constructed and be like, oh, that's maybe not what I want, or like, I don't know.
Yeah.
Pretty.
Yeah, okay, that's right. Sorry, I was doing mental math for a second.
You're good.
4, 2. I honestly just want to get this finished, so I'm kind of just going through it quickly. 826. 826. 5 more questions. Wait, does it want it to... Okay, so we're using sides again.
You have all the sides this time.
Yeah. I mean, the nice thing is that the function is already written, so all I have to do is just add in the numbers. And I'm surprised we have not gotten another decimal yet. That's actually really nice. And there's no triangle. That is really useful.
When you have to when it's easier to create a function called add decimal to number than just implementing the logic.
Yeah.
Takes in a whole number, takes in a you can do that technically. You can just write a function called add decimal to number, and all it does is
the number in the decimal.
Takes in the number, the decimal, and then how many places you want to shift that over.
Yeah. I may do that.
Like to make the number 10.24, right? You could have a function that takes in 10, it takes in the number 24, and it takes in a 2, meaning move over.
Yeah.
Oh god.
Now you have me debating on doing that. Because as soon as I said that we haven't gotten decimal points yet, we get decimal points.
You could also multiply everything by 10. And then divide by 10.
Yeah.
And since your language can handle decimals once it's computed, then it works.
Yeah.
So take in 206, 154, and 320, and then divide that final answer by 10.
Fuck it. That's what we're gonna do. So,
Yeah.
So we'll have I'll say, what's a good? We'll say because we're already using A. So actually no, because we're using A as if no, we'll use call it side A. Side underscore A, which is then equal to 260 or 206 divided by 10 should return that.
Yeah.
Have side
I
of...
was gonna say just put in side A, put in 206, put in that, and then divide the answer. Just know that you have to just move the decimal over by 1.
This is more fun though.
So you don't have to write 10 every time.
Yeah, it's
Yeah.
more fun doing it this way. Probably a lot more jank, but yeah,
Someone's gonna tune in being like, "What is he? Why isn't he just typing 206?"
Whatever. Alright, so now... Hey, look at that. There we go. Thank you for that idea. That is actually really nice. So we have 31.894. I should probably check. I know these are correct, but just for sakes, actually make sure this is correct. Okay, yeah, no, that's correct. Cool. Just had to make sure. Cool. And then B is...
Wait, really? I didn't know Math.js had conversion. You could just type a string like 12.7 cm to inch, and it gives you it in inch. Really?
Wait, really?
Yeah, that's kind of cool.
That's actually really cool.
So it has language processing ability to know cm to inch is what... Huh.
That's actually really cool.
That's nifty.
894, 23.265. 124.841. Yeah, okay.
And you know, since you're using Dino, you can't use npm packages the way you would expect, right?
Yep, I'm aware. Because I tried doing that already in the past. I found that one out the hard way. Yeah.
So you can do it. You just have to remember the to at npm or npm colon the name, and then if you want the types for it, then you'll have to do less, or what is it, comment less than reference, then you put npm at types / Math.js, the version number, something like that.
Gotcha. Alright, I'm feeling really lazy now. I don't feel like typing out all the logic, so we're going to use pre-made logic.
Area of the triangle having the given measurements: an A, a C, and a angle B.
This is for if we have side. We need side-side angle, which is, this is side-side. Oh no, this is angle side-side. Cool, that's, yeah. So we have A, which is 15. C, or B technically, which is 42, and then 30. So I should probably explain this, huh?
Oh, that's fun.
Well,
I'm not the one doing the math.
yeah. Well, I understand the math because I did it a shit ton of times. Because our teacher gives us like, my teacher gives me a ton of problems to do, and then I actually have to do them, and that's fun, I guess. Not really. Kind of sucks to be honest.
That's how my oh my god, dude. That's how my calc and my discrete this semester is like exactly like that. Every for example, today, sorry. We had to, what did we have to do? We had 12 problems. That may not sound like a lot, but in discrete math, like the units we're in is like combinatorial proofs. And it's like, it's just, they're very long. So my math homework was 14 pages today.
God.
Turned in. And that's typed up using LaTeX.
Okay, yeah.
And then, yeah, that's just long. So like we get really good at them, but I feel you. And then like calc was the opposite. Calc 1, like I don't think we had many homework. It kind of was. I didn't like it. I like to be forced to be given problems to do, because then I'll do them.
Yeah.
But if I'm just, like given the bare minimum, then I won't do all of them, and then come exam time, I have to really study hard more.
Yeah. Which is the, okay, so this is going to be 157.5. Yeah. I like having homework because it forces me to try and learn actually how to do it correctly. At the same time, I hate homework because I'll end up forgetting about it, which is the part that sucks. This is using this is using Huron's formula, because in this we need to find what S is, and then from that we can figure that out. Which is this correct? Yes, that is correct. But that gives us only the area. That does not solve. Oh no, it does solve, because then we square root that. Yeah, okay, no, that's right. Okay, yeah. Sorry, I had to think about that one for a second. 14, 9, 22. Because to solve for S, you would do A plus B plus C divided by 2 would give you S. And then you do the square root of S times S minus A times S minus B times S minus C. So this is just basically combining all of that into one formula. To then solve, which would be, I infoed it. Why did I info it? Which would be 35.93. 35.93. I really hope I didn't fail this. That would suck if I did. Fucking story problems. Why do there's gotta be story problems?
Yeah, I'll send you this. This is the kind of stuff I want to make videos on, because it's kind of cool. But really, like, these, I'm not gonna lie, are the hardest problems I've done in math. But they're so satisfying, because they're so...
Oh, the fuck? Oh, no.
So go down to 3. That one's actually kind of like... so go down to exercises, and then 3.
So
you actually...
Did I go too far?
Yeah. It's section 1.4. 1.4.
1.4.
Combinatorial proofs.
Sorry.
Oh, so it's just combinatorial proofs.
Okay, combinatorial proofs. I see it.
Okay, and then go down in this into number 3. You'll see it when you get to exercises.
Oh, the example 1.4.
No, go down. It'll be exercises.
Okay.
There we go. So 3. So it's like, how many triangles can you draw using the dots below as vertices? These are really fun. I like these because...
1, 2.
Oh, yeah, you'll never get it if you do that. It's a big number. Very large number. So one way to think about it is you're like, okay, how in the hell can you do this? Well, think about it, right? What isn't a triangle? 3 dots on a line, right? So how would you say, so there's mathematic notation, which is called something choose something. So that, what you see above is like X choose 2 or Y choose 2 above on line 2C. That's notation saying, using the Pascal's triangle, you can find out what 5 choose 2 means. It says, given a group of 5 things, how many ways can you choose 2 permutations of it, or combinations of it? Yeah. So, given 3 letters, A, B, and C, how many ways can you choose 2 of them? Well, you can do A and B, A and C, B and A, B and C, C and A, C and B, right?
Yeah.
And then notation for it is 3, like 3 letters, choose 2. And you'd use that triangle up above to compute it. So you can look at the triangle and go up. You can think of it like this, though. How many ways are there, given the 7 nodes on the bottom, right? How many ways are there to choose 2 of them? Because you can never have 3, right? So you choose 2 of them, but then you also need to choose 1 of the top circle, right? Because that gives you 3 points. So 7 choose 2 times, there's 1, 2, 3, 4, 5, choose 1. So that's choosing 2 on the bottom. But what about choosing 2 on the top and 1 on the bottom? Plus 5 choose 2 times 7 choose 1. Plus, what if you just choose 3 on the top? So that's actually the answer to number A.
Oh, jeez. I got lost pretty
But
soon. But I mean,
well,
it makes sense though.
yeah, and it's like, or it's like given a group of people, if everyone wants to shake each other's hands
Hmm.
and they want to count, wow, they want to count how many ways can this be done such that everyone shakes each other's hand once, right?
Yeah.
Well, if there's 10 people in a group, you can think of it like this. The first person will shake everyone's hand 10 times, right? But the second person will shake everyone's hand 9 times because they've already shaken hands with the first person.
Yeah.
In the third, and so on. And when you get to the 10th person, they'll shake everyone's hand 0 times. They'll count it at least because they've already shaken everyone's hands through those other people. So that's that. Yeah. Anyway, I have all this fresh in my head. Don't worry, it was confusing as shit. But this is the kind of homework, and it's like 11 problems, and it's like you have to write out a proof for it. And the way you do combinatorial proofs is usually it's very formulaic though. It doesn't sound like it, but it's very formulaic. There's two. You make a question that makes it work, right? So you solve the left-hand side, you solve the right-hand side using a different method, and then you say, well, since they're counting the same thing, they're equal, right? Like that's your kind of proof. But it's kind of cool. I don't know. So, but anyway, the homework like this, we have our exam coming up in a week and a half, and there's so many homework questions, but I think in a way it's good because when the exam comes up, we've done so many of these proofs that the first couple were terrible. Like it took about 10 hours or so to do this homework, you know? But by the end, we were zooming through it. Like me and my buddy were like, damn, dude, I thought for a second, there's no way he's making us do 11 of these, right? And we started doing it and like, it got easier and easier. So I think for like trig, I think it's good that a professor gives you, or a teacher gives you 50 problems. If they only need to give you 20 to do it, right?
Yeah.
I think giving double or whatever is like... Plus, then if a teacher gives you way too many problems on homework, it means that if you can do the homework confidently, you can do the test confidently.
Yeah.
So you don't have to study. Is kind of what I like.
Yeah, it makes sense. Yeah. Yeah, like my teacher gives us, I think, around maybe 10 to 15 problems on the board that we do. And then we have our math lab assignments.
Oh, you guys do like in class?
Yeah.
Okay. Yeah, Calc was a lecture, and Calc 2 was a lecture, so we couldn't do board stuff, sadly.
Oh, that's so fun.
But this class is just like that. We have activities in fact, one day of the week, all we do is go. In fact, what's interesting is we can still get answers to these homework problems in class.
Really?
Kind of. So, for example, I'll give this week's schedule, right? This week, we went over the answers to the homework that's due on Friday.
Uh-huh.
We literally could ask any question on the homework, any single one, any proof, anything, and we'll do them in class. So usually, with it there being like 11, I think there's 13 questions on the next one, we were able to ask 3 of the questions. So it means there's a guaranteed 3 questions we got right on the homework. If you just asked, right?
Yeah.
But it's so it's very interactive. We come in, everyone gets to get up in the room because there's only 8 students in our class. It's really small, and everyone just gets on a whiteboard. He gives us a pen, and we can all just come in, pick a whiteboard, and we can just write down a homework question we had. And he'll go, and then we can all work together for the first half of class. We work together. So I will go over to a classmate who couldn't solve theirs, and maybe I was able to do that one, you know?
Yeah.
I'll go over there and help them with that one. And they'll come over to mine and help me with mine. And then at the very end, if anyone's still confused, he will come around and we'll all kind of follow him around and we'll do a problem on the board, you know? So it's like very interactive, and I love that so much.
Interesting. Wait, hold up. So it's asking me how far the receiver will run to catch the ball.
A ball is kicked at an angle of 15 degrees to the right of the receiver, standing 75 yards away from the kicker. I'm trying to figure. The kicked ball travels 76 yards. Oh, okay. How far must the receiver run to catch? So you just need to find side little c.
Yeah, which would be 19.734 yards. But that doesn't seem right, though.
An angle of 15 degrees, 75. Well, okay. What you could do is to double check your work, you could use the you can complete one of the angles using the law of sines and then see if they sum up to 180. And if they do, you're done.
True, yeah. Alright.
So you can take that as the answer and say, okay, if that's true, then if I compute the law of sines for, let's say, angle A, right? And I sum, A plus 15 degrees has to be 180. If it isn't, then that angle that helped build A is wrong, right?
Yeah. So then we could say, just have a check to see. So we'll have a check to see.
Block right, doing it in code.
One more time?
No, you're fine. I was just like, I forgot you're doing it in code, so it's just funny. You're like, oh yeah, and then we just write this check that works for every possible thing.
Yeah. So we'll say that have a trace, and then we'll add angle A plus B and plus C, and if that is equal to 180, then we know that these are correct.
Oh.
Yeah. Okay. And
There we go.
180. So that is right. That's weird. I thought it would be longer, but I guess it isn't.
Well, the throw was so incredibly far.
True.
You can think horizontally on a field. If the quarterback is standing in the dead center of the field, I would assume for this would have to work.
Yeah.
And they throw the very far left end zone corner, right? The receiver, if there is on the far right end zone corner, would have to run about the distance, the width of the field, almost, because it's 75. If it was 100 yards, it would be the exact width of the field, right?
Yeah.
So I guess it makes sense. 19. I mean, I don't know how wide a field is. This is obviously kind of exaggerating some data, but
yeah. Let's see how well I did on this test. Okay, that's actually not bad at all. All right. Which ones did I get wrong then? Let's see. Oh, these were ones before I started streaming. I think this was the first one. Solve the triangle. So these are the correct values. I inputted the wrong values. Angle, side.
Angle, side. 18. Well, you already can find what big C is, can't you?
Yeah, we already know big C and big A, so all we'd have to do is find B, which would be 55. And then we have sine of C, so we can find... Oh, I think I see what I did wrong. Because don't we have to use the law of cosines here to solve this?
Not necessarily. We could use whatever method. Given two angles, it's easier to use the law of sines, I think.
Yeah, because
you given 3 of the 4 values, which means you want to set it up. So, for example, B is on the numerator. How would you do that? You flip the reciprocal, right? Yeah. So that means to find B, you do B is equal to. So you can say sine of B over B is equal to, right, sine of C over C. But you want it to be flipped. So you need to flip the reciprocal, right? You need to multiply by that. So that gives you B is equal to, so B, you can rewrite it, I think you can, as B over sine of B, right? Equals B over sine, or C over sine of C, right? Which you know what those are. So that means it's sine of, or it's, what is it? C times sine of B over C. Or over sine of C. God. It's hard without writing it down in your head.
Yeah.
I think it'd be like that.
I understand that problem. I'm trying to see where all these other console logs are coming out so I can actually see the one I want to see. Because I found the function where we're calculating this, but there's another one being shown. Because it's this one here. So there's probably something wrong in here that I did incorrectly. But I'm trying to get all of them all the console logs to disappear so they're not cluttering everything up. There we go. Alright. So this is the problem here. Oh, no. Okay. I see why. So the reason why these answers are wrong here is because originally what I did, and I realized this afterwards, and I didn't check it, was I did it like this. So I had sine of A, so I'm pretty sure it was this one. I had this one open, and it was like this, which was the problem. So now if we run this, we'll get these values. Oh no, but they're still the correct values. So how did I fuck that up? No, they're not the right values. But I did something like that, and that's what screwed me over. So I see what I did wrong. Let me just double check, make sure these are the correct values now. 15.
4, 6, 8, 4.
Oh no, so these are the values I put in. So no, my math is wrong in here, because these are the correct values here. So then what did I do wrong in my math?
Well, side A is right then, right?
Yeah, side A would be 18. So we know that side B, or angle B, is correct. But side B, or side A...
Oh, I see. It gives... Oh, I'm all confused. I'm like, what are you talking about? It tells you the right answer is what you got.
Yeah.
It's inverted, so out of my... We use MyOpenMath for everything.
Oh, okay.
And I'm over here like, what? Your answer is right. I'm confused. It tells you got... Okay, I see. Okay.
It gives you the corrected answer, and then I answered
13 is
that.
the right answer. Okay, it's invert... I'm like, what?
Yeah.
What are you talking about? Okay.
So, what did we do wrong?
Solve for the triangle. Given an A, a B, and a C. Okay, so given two angles, and... Well, okay, think about it. Is... a little c, so A, a B, and a little c, so that shouldn't matter. So to find the angle of C, we should take those two. Subtract 180. That's good.
Yeah.
Find side A. So to find the side that goes along with that, you would take C times... So you take the little side. So to find side A, you do C times...
the sine of A, big A, divided by the sine. Oh, wait. Is it because I used, no, it shouldn't be because I used C. That shouldn't matter, right? I shouldn't have to use B, no?
I'm trying to think of how to try. I'm literally just drawing out a little triangle like this. Just to...
So
that'd be A is 18, C. Okay. So big A is 18. This is 107. That means this is A, C, C, B, B. Okay. Little c is 41, 41. And this is 107, 18, 18, 18. So we like 50. Oh, you already have the answer, right? 55. Okay, so that means what we could do is we can use... So to solve for... What angle is we trying to... Little a, right?
Little a.
Okay.
Yeah.
Little a would be, so we know that sine of 1/8 over little a is equal to, we know c, okay, so we'll do sine of, what's c, 107, all over 41. To solve for both sides, we can multiply by a over sine of 18, so that gives us... Wait, am I stupid?
That's what I'm saying. That's what I'm thinking. Like,
yeah, I'm just gonna do it in one step. I don't know why this. Okay, so it's a wait, not omega. What am I doing? A. I started taking the derivative for some reason.
Oh, that's not good.
So it's a sine of 18 is equal to a sine. Oh wait, we cancel the a. I'm so stupid. Sine of 107 over 41. Okay, which means now we can multiply by 41 over sine of 107. Okay, yes, that's what it is. So it's A is equal to sine of 18 over sine of 107 times 41. So little a is equal to sine of big A times little c, all of that over sine of big C.
Yeah, that's what I have.
Little c is 41, right?
Yep.
Yeah, cool. Times, and you took that whole thing and you did sine of... Your parentheses are wrong. Something's wrong with your parentheses for sure.
It has to be.
You get the blue. The blue... Wrap that c times that to make sure, for sure. I mean, again, it shouldn't matter, but I still think something's weird here. So just wrap that in parentheses as well.
Yeah. Okay.
That's weird. But yeah, I just did the algebra.
Yeah.
You're right. We got the same thing. I didn't even look at your answer.
So I'm not going crazy then. Yeah, it's so cute. The fuck?
Wait, find angle C is an array? What?
Where are you looking?
Go back to the code. Why is that is that an array?
No. So this is the computed value.
Oh, I don't know. I'm like, what the fuck is happening here?
No, that's the computed value. You can either have it as a dot or as the dot property, or you can call it as the computed value. You never finished setting it up. You never wrote the back end of it in the series. So in one of the streams I did, I finished the back end. No, I got it working. It took me 2 hours to do, but got it working.
Fine. Okay, let me redo my math. What the hell?
Yeah, now I'm confused. Hold on. Let me do the math too. Because the only thing I can think of is that we have to find b first and then solve for the sine of a divided by a is equal to sine of b divided by b, maybe? So, hold on. I'm going to do the math too as well.
Okay, so a is 18, a. Okay. Means little a, we don't know. Okay, b is unknown. Oh, actually, b is 55, b. This is little b. This is little c, and this is big C. C is 107. Okay. Little c is 41. Okay, so I have it all drawn out.
B.
Okay, using law of sines, because we already have so much data. Using law of sine, we should be able to do sine. I'm pretty sure. Can we just flip everything and say they're equal? We should. They're fractions.
I think you should be able
should.
to. Because you need to cross multiply the sine of b and c, and then the b of sine of c as well.
Law of sines. Big. Can I do like law of sines reciprocal? Reciprocal. RECRIP. Holy cow. I can't spell reciprocal. There we go. Yeah, okay, yeah, you can do that. So it's a over sine of a is equal to b over sine of b. Yeah, okay, so I think you can do that. Yeah, so we don't even have to do the algebra like that. We can do a over sine of a, which is sine of 18.
I figured
is
it
equal is equal to 41 over sine of 107. Which means we multiply by sine of 18. It's not exactly in my head. What the fuck?
So I figured it out. So the reason why I got the wrong answers is because I tried finding side A first. And so the reason why it's wrong is because all I had to do was just find sine B. And here's why it's wrong. Is because we're trying to find the side of A using the sine of C divided by C. Whereas the formula is sine of A divided by A is equal to sine of B divided by B is then equal to sine of C divided by C. So the first thing we need to solve is we need to find B. And then once we find B, then we can solve for A. That's where I went wrong.
Just so you know, we can also do it where we don't have to find B first. We can go in order of the questions.
So sine of A divided by A is equal to sine of C divided by C.
Use this copy image. I'm going to send you a formula, which is the same formula, but just showing that the reciprocals identities work.
All right.
So law of sines, if you know the angles, right?
Yeah. Which
If
we
the
don't
right hand
know
side, we know c and little c. So we can do sine of a over sine of a equals c over sine of c. We don't have to do the b.
Yeah.
So a over sine of a, so that'd be a over sine a is equal to c over sine c.
Sine of
Like
equal.
this. And if we were to solve for both sides, or solve for a, right, or big A, so that's a big A and a big, I don't know why I put an X, wow. Sine of C,
Huh. Okay,
this would
yeah.
be sine of, and then that gives us, right, to solve for both sides, you would then have A is equal to, multiply, oh, I don't know how I got, wow, I'm bad at math. Sine of A. Okay, so then A would be, right, multiply both sides by sine of A, would clear the sine of A, so that would give us C times sine of A,
Yeah.
all divided by sine of C.
Yeah, and that does give you the right answer. I just did the math on it too. So I had to have programmed something wrong then. So where in the program did I go wrong? So we first calculate angle B, right?
Mm-hmm.
So now we have the B, right? So now, oh, I think I know why. It's because we're using, this should be B. I know it doesn't make sense, but the reason why is because the B here is our C, technically. So if I clear this, there we go. Yep, okay. Even though now side B is incorrect, because why is side B incorrect now?
Well, because now we use the result of A.
Yeah. Well, no, it's because we use the sign of B here when we should be really using our angle of C. So
The issue is you don't know which
yeah.
Since the sides have to be opposite of each other, it is important the way you put it into this thing, right? If you swapped A and B, it would actually be different, the parameters of this function.
Yeah, there we go.
It's kind of messy, I won't lie.
Just a bit.
That's
okay.
funny.
But that does it. Okay, so it was a programming mistake.
Yeah, I'm like, okay, I did the algebra the hard way and the easy way, and both of them came to the same conclusion.
Yeah.
That's proof by not trying it again.
Oh, I did this wrong? How? What? That's not correct. Because you have to split the triangle in half to find the distance between the two canyons.
Yeah. Yeah.
So then where did I go wrong? Hold on. Okay, let me find...
Or you can say it's yeah, I mean, either way. There's a couple of ways.
Yeah, because A would be 90 degrees because you're just splitting it into two right triangles. So then you would have to find the side of B.
Wait a minute. Whoa. Slow your roll here. Not necessarily, right? If you were to think about it, if you drew the line between C and that, right, you get a 90-degree angle, and if you already know what B is, right? Yeah, you already know what angle B is.
Yeah.
And you already know what angle C is, right? Because
Yeah.
you can divide it by 2, and that gives you the split. That means you can use just trig. Like, not law of sines, cosines. Use trigonometric functions. So you know that the adjacent would be 57 divided by 2, right?
0.5.
That would be x. Y would be the distance you're trying to solve for. In C, you already know what CB is, the length.
Yeah, okay.
So you just do, we know what x is, we know what the hypotenuse is, we would use, we want to find y. So what does that mean? We use sine inverse, right? Or no?
No.
I'm sure there's many different ways. We could also use this law of cosines, but that's just the first thing that came to my head, is just use trig, like sine. We can use you can use different ones, but I don't know how they would want you to do this. Technically, that might be more work.
Yeah.
I don't know. It is kind of a bit more.
I'm not even gonna touch this one, even though I'm pretty sure I did the math right on
The
this.
figure shows a 1,150-yard long sand beach. Okay. And an oil platform in the ocean. The angle made with the platform from one end to the beach is 82 and the other is 77. Okay, cool. Find the distance of the oil platform from each end of the beach. Okay.
Yeah. So from here to here and here to there to the platform.
Yeah, so first thing I would do is I'd find the angle. We can figure that out really easily. And then I would use law of sines where 77, let's say, is B, right? So, and then we know that C, we know the angle in the side, so we can use law of sines for that, and law of sines for A, and either C or B now since we found them.
Yeah. So I got one of them right. I just put it in the wrong spot, which probably is where I went wrong.
31 point, wait, what?
So for this one here, I did get the right answer, but I did it backwards.
Because you probably had to put the larger one
Yeah.
on the... That's kind of an... Oh, yeah, it says use descending order.
Yeah, I didn't read that far. I'm a dumbass. All right.
Nice.
Yep.
Well, yeah, your function's working.
Yeah.
Mostly. What is that?
Why is this
30.
So this is just... It takes a whole range of numbers. God damn. Oh, okay. It's basically the same problem that we ran into here, where I mixed up the values again.
Yeah, because you have two angle, or it's what is it? Side angle side.
Yeah.
Yeah.
And then, oh, whoa, what? Okay, hold up. What's wrong here?
I don't think so. That is, what is that? That's side angle or angle side.
Which we did here. Oh,
No,
again.
no, it's angle side or side angle.
Yeah, angle side.
No. The SAS is different than
No,
AS.
I named it
Or
SAS for some reason, but if we look at the values that were being added in, we take in.
Okay, yeah, it is ASS. Yeah.
Yeah.
Okay. Yeah, it's like they are different.
I know that. I swear, I know they're different. I could promise that.
Okay. So.
Yeah, I just did the value again. I did the same thing, the same mistake that I made up here, where I tried to use different values and. Bungled.
Yeah, I think the only way you could do this intuitively is to take in little a, little b, little c, and big A, big C, and just whatever you leave undefined, you have like, you know what I mean?
Yeah.
That way you'll never get it all screwed up, you know?
Yeah, that would be definitely useful.
If you were to include those as an actual function, I guess, like in your standard library.
Yeah.
The funny thing is, though, if you implement these correctly, you can then take this source code file and add it into your standard library.
Yeah, and then no one would have to suffer through the pain that I go through.
Yeah, you can create a language made for trig and calc students passing their classes.
Yes, just to cheat. Gotta love it.
Yeah.
All right.
Yeah, nice. Well, I'm gonna get off, but yeah.
Yeah, same here. Spent
Have a good night.
3 hours.
Good. Yeah, glad. Hey, I'm actually happy. I'm glad we were able to really quickly get that fixed with the members. Members that I think are like cool because they really open the door for like. There's so much you can do with static methods, right? You don't have to populate scope. You can just. The beauty of it is you can see you don't have to duplicate that function everywhere. Yeah. So yeah. Well, I'll talk to you later.
Alrighty.
Let me know when you get your modules all figured out.
Cool. Will do. Thank you. See you next time.
Bye.
Bye. That is a super cool dude. I'll probably have his YouTube linked in the description. He has a series making his own language and everything in TypeScript that I followed, and then I took what the basis of what he had and added onto it greatly. But he is super cool, super really helpful, really chill person. I'll probably link his YouTube right now. Plug it. Let me see if I can find his YouTube. I know I'm subscribed to it. Ah, here it is. This is his YouTube. Really cool person. As you can see, he has a whole tutorial series on basically walking you through the basics of making your own programming language in TypeScript. Super awesome, super well series, a lot of theory in it. Really cool. But with that said, I'll see you guys in the next stream, which I don't know when. But yeah, hope you guys have a great day or great night. It is currently 10:31 for me, so I'm going to go to bed and leave my desk a mess because why not? With that said, I'll see you guys in the next one. Peace.